Hello everyone, welcome to Generative Geek. This is the second video of our embedding course where we are learning about embeddings and how you can implement them using OpenAI. I have not yet touched Google Gemini models, but I'll touch them in a little later, one of the later videos. So let's quickly recap what we did in the first video. So in the first video, I gave you a sense of what embeddings are. We took some sample text, we generated embeddings using OpenAI. For the purposes of this video, we specifically used text embedding 3 small model. Then we looked at the response of the embedding. We saw what are the various keys that come back as part of the response. Then we took some text, and text that was similar in intent and context, and text that was dissimilar in intent and context, and we use that text to see how actually the distances between these texts look like, right? Embedding largely converts pieces of text or documents into some sort of a vector, right? Which is a dense vector, multi-dimensional dense vector. Largely, when you look at the list, it'll look more like a series of numbers, right? So, but they are representations of the text in the vector space. Then what we did is we used the distance method from scipy.spatial and use distance.cosine to find cosine distances between the two embedding vectors. So we had, like, let's say one block of text and we had another block of text. We computed the embeddings for both of them, and then we brought in the cosine similarity and said, hey, how far are these two embedding vectors from each other, right? And embedding as a concept helps you get the vector is placed in a way that the model is able to understand the context and intent, and then it places that the vector. So more similar, differently put, more similar sentences, similar in the sense of their meaning in terms of semantic meaning, similarity, context, intent. They will be placed more closer. Then I took a more real life example and said, okay, let's do product search using embedding. So we created a hypothetical product catalog with title, description, price, category, features of several products. And then we calculated embeddings for these products, right? So we created what we did is, now products, you can either just use the title, which we did earlier. In the first example, we just used the title, and then we did more rich, we created a more richer string with title, description, category, and features to say, hey, you know what, sometimes the titles are not written appropriately, or the title might not do justice to what the product is, and therefore a more richer info text will be useful. So we clubbed various attributes of the product and created an info text. Then we created the embeddings of these info texts. Now once we have these embeddings of info text, we said, okay, now there is a query that is incoming, like, let's just say summer shoes. That's a product search query. We created embedding of the summer shoes as whatever is the query, and then we compared that embedding, we computed distance of that incoming embedding with all the other embeddings we have, right? And whichever were the closest ones, right? We printed those. So we found comfortable sneakers had a distance of 0.52. Now, smaller the distance, the more closer they are in terms of similarity, right? So stylish sunglasses, you can see, has a much higher distance. Obviously not a summer shoe. Flowy maxi dress is probably a summer thing, but not shoes, right? Warm winter scarf, you will see the distance increasing, right? And then what we did is we did some sort of visualization. So I used PCA to decompose the metric, to reduce the dimensions, and then project all of those on a 2D scale, right? And all the products on the 2D scale. So we took various embeddings, we reduced the embeddings, we took Euclidean distances between the reduced embeddings, and using k-means, we then clustered them. Here, I think we have taken 5 clusters, and therefore you see 5 different colors: green, yellow, maybe black, and some other colors, some other very similar looking colors. But what was very important and very interesting was that if you saw products across different categories, but similar stuff like, was like, clothes all were like, clustered closer to each other. Sneakers and sunglasses were closer to each other. Products around the grocery came closer to each other, right? And this was all done through embedding. We were not doing a category match here, right? So, and then T-SNE we did not cover, but it's part of the notebook, which you can see in the description. Now we are going to get further here, and I'm going to now build this notebook with you. And my goal here is that, from this point, what we'll do is today's agenda is very simple. I'll not go through a lot of stuff today. But my idea is that, hey, how do we do recommendations using embedding? So we have already seen search, and now we'll see recommendations. Now, if you look at recommendations, right, you look at any online retail, recommendations generally work on what are the products that you have already been seeing? What are the products that you have already been buying? What are the products that you like? Are there products that you have been adding to your cart, or are there products that you are adding to your wish list? And basis that, there are algos, very specific algos that will look at that data and then start recommending you products. We'll not get into those fancy algos right now. I want to give you a sense of how using embeddings as a concept, if a recommendation system had to be built, how will it look like, right? So let's say we want to build a system where whoever, if you were looking at a product, if you looked at some product, and now you want the system to recommend you basis what was the last product that you viewed. How can it be done? So let's just say I have this product which I'm calling the last product. Now this has a title, this has a short description, this is a price, this is category, it has all the features, and this is probably part of one of the product that is there in our product catalog, right? Now if I looked at this product, I want the system to start recommending me new products, right, or similar products, but not this product, right? That is how I would ideally want the system to work. So what is it that we will do? We'll create a product info text. So the thing remains the same, right? Let's say the thing remains the same. How does it work? Right? What we'll do is we'll create an enriched product feature set, enriched product text using the various attributes for the last product, right? So now in our case, we are only looking at one product, but you can have a more complex list where you can say, hey, you know what, I'm going to look at last product. I'm going to look at the last product the guy added in their cart, person added in their cart. I'm going to look at the last product that their friend bought, maybe. Why not, right? So basis all that, let's just say you have a list of products, right? The method is still the same. You will look at those last products. You will then, or you will look at the products basis which you want to recommend, and you will create embeddings of those products, right? So we'll create an enriched product text. Then we will create embeddings of this. We'll create embeddings of the rich text. We will compute distances of the products in the catalog with the last product. Print nearest 5, nearest 3, excluding the product in the last product list, or the product last visited, right? You don't want to recommend the product that they have already visited. So this is how it will work. So let's start. We'll basically first combine the features. We'll say, hey, last product text. Let's convert this back into Python. Shortcut key, if you are on a Mac and you want to quickly convert, go to this place, deselect the cell in a way, and then just press Y, right? So it will give you, if you want to again convert it back into Markdown, press M and it'll go back to Markdown, right? So let's press Y, sorry. press Y, and I'm back in Python. So last product text is equal to create product info text, and we'll pass in the last product, right? So this is the method that we created earlier. Now GitHub Copilot is suggesting that I probably, because I have already written my comments or my description in the markdown. This is one great way of grounding the model and telling it what you need next, right? So embedding of last product, right? So embedding of test, embedding of last product is equal to create embeddings from text, last product text, and 0, right? Okay, yeah. So before we actually do the embedding, let's do this. Let me, for the sake of refreshing our what we did earlier, let's just print last product text, right? So we'll create this. Okay, last underscore product. What is the error? Error is description. Okay. Yeah, so this is the text that I'm getting back, right? And so now with this text, let's create a embedding, right? So if you now look at embedding of last product, you can see it's all bunch of numbers, right? And if you look at the length of this, it'll be 1536. This is something that I had explained earlier in the previous video, so I'll not get into that. So now we have the embedding of the product, and we have embedding of the last product, and I think we already have embeddings of the product catalog, right? So, but let's say if we don't have, we can again create one. Product underscore text is equal to, we can call create product info text, product for product and products, right? So what I'm doing is I'm doing the same thing I did with last product text, right? I'm basically calling the product info text method on each product that is there in the products list, right? So this will give me, if you want to just have a look, we can just say product underscore text, maybe the first 5, right? So this is, each product gets broken down into its F string, and we have a list then of such product text, right? Now let's create embeddings. Last product embeddings is equal to create embeddings from text, last product text, last create embeddings from text. We need to pass, let me just look at the method ones. Create embeddings. Okay, we need to pass an input. Input is basically the string, the list, and the model. Model is defined. Yeah. So let's say we'll say create embeddings from text, and we'll pass last underscore product underscore text, and we'll say okay. This should make last product embeddings available. We'll also do same way product underscore embeddings. For all the product text that we did. Create embeddings from info, create embeddings from text, product text, and now we have both these embeddings, right? So from here, what we want to now do is we want to basically, and if you remember, we created a method which we called find closest. Did we or not? Find n. Okay, it looks like we did not, but we can now. So if you look at the task we took on ourselves, we said we'll create an enriched product text using various attributes. That's done. We'll create embeddings of the rich text. That's done as well. We'll compute distances of the products in the catalog with the last product. Now this is the part that we need to do, and then we'll print the nearest 3. Now, in order to compute the distances, what we'll do is we'll just create a method that will then go out and calculate distances between these two methods. So let's just say that method we call find n closest products. Okay, and if you look at it, it's kind of giving me some code, right? For now I'll not take its recommendation, though it looks like the recommendation is all right, but I'll walk you through what I'm trying to do. So I'm saying there is a query vector I want, embeddings of the query vector, basically embeddings of the query vector. Then there are embeddings of product vectors, and how many nearest I want for the purposes of this one, let's just say 3, right? So after this, what we do is we'll create an empty list called distances. I will say for index comma embedding in enumerate embeddings of product vectors. So we are going through each embedding that is there in the product vectors, each embedding of product vectors, and we are appending distance in the distance. So we are then computing the distance between each embeddings of the query vector and embedding itself, right? So we have this list of product vectors, list of product embeddings. We are taking each one of them and computing distance of that with the query vector. So there is a query that came in, summer shoes. We calculated embedding of that. Now that embedding, which we are calling the query vector, and the catalog product from the catalog, both of these, what we are doing is we are taking them and then we are calculating distance between these two. And whatever is the distance, we are then appending that distance into the distances list, right? After this, it's very simple. Once we have the distance, we just go out and we sort the list basis how's the distance looking like. So distance underscore sorted is equal to, we'll call sorted on distances, and we'll say key is equal to, we'll create a lambda function where x is x of distance, right? So we are sorting on distance here, and what it should do is so when we basically went through the entire loop, it created a list, but it did not sort it basis the distances. Now we are sorting it based on the distances, and we are using the key as the distance here, right? So we are sorting based on what is the distance, and then we want to return distances underscore sorted. The first n elements from that is what we want to return. I hope this is clear, right? So we will create this method, and then we'll come back to what we were doing earlier. I will say, okay, now that we have the method and we have our queries, let's call them as closest products, right? Find and closest products, embedding of last product embeddings, n is equal to 3, right? And we'll run this. Okay, has no attribute cosines. I think there was some spelling mistake. Cosine, yeah. Again, invalid index to scalar variables, distance sorted is equal to what is wrong? Distance sorted. Now, so I can just edit these things, but there is a lot of learning you get when you get an error, and you want to you go through the error and you're trying to solve the error. So let's look at what the error is trying to say. Invalid index to scalar variable, and it's telling me it's coming in this method, and it's specifically in this line, right? So it's sorted distances. So I know what I need to basically look at, right? And this is the most important thing. I think the challenge is when we were adding, and this is what happens sometimes when you're looking at only the GitHub Copilot code, right? When we computed, there was no key, right? There's no key called distance that we added. So we need to basically do that. We need to say, hey, you know what, before appending things to this, so we'll make change to the code, right? So I'll say dist is equal to distance dot cosine and embeddings of query vector and the embedding, right? So this will give me dist. This is basically the distance, and now I'll say distances dot append, and this is where we'll basically bring in a dictionary and we'll say, hey, distance and whatever is the distance, right? So dist is the distance, and we'll add an index, because when we'll sort, we'll need this index. Otherwise, there's no way to look back, right? And I'll explain to you what I mean. So this is what we'll do. After this, we'll say closest products, and now if things have gone well, what would have happened is we would have got all of these closest products, right? So for product and closest underscore products, let's just now start printing the product, right? So product is equal to, and if you remember, we had added index here. So and that was the reason, right? You know, because product is there is also a list called products, right? So I'm taking the product from there and the index and putting it here and calling it that the product, right? So maybe too many products. So in close for underscore, or maybe let's just say for prod in closest products, because I don't want you to get confused with so many products, right? So for prod in closest products, what we are saying is the actual product is, we're taking the products catalog that we had earlier. We are taking this prod that we are looping through right now. We are picking the index, and then we are calling that specific index of the products, right? So, and this is our product, right? So we are just going to loop through it, print. So these are basically our Action Camera Pro, compact Bluetooth speaker, and organic vegetable box. Now let's look at what was the last product that we visited, right? You know, so last product was building blocks deluxe set. Unleash your creativity with this deluxe set of building blocks and endless fun and all that, right? While it doesn't look very similar, because there's one camera, and that's because the product catalog itself, if you look at the length of products, how many products do we actually have? We only have 19 products. So there's not enough fragmentation in our products right now. There's not much depth. So this is what we are getting. Now let's just say you want to add user history to the recommendation engine, right? You know, so this was the first part. Now let's add some sort of user history to the recommendation engine, right? You know, because if I'm just recommending basis one data point, that'll be inefficient, right? Or insufficient. In these cases, you know, what you ideally need to do is if you want to keep making your recommendations more accurate, you need to have more larger history. And if you have that larger history, you can create even better recommendations. So we'll basically go ahead with that. We'll create something called as a user history. Again, very similar to what we have already seen. The concept largely remains the same. Think of user history as a list of your last products, right? You know, so let's say instead of one product that we had in the list, in case of last product, we now have multiple products, right? So user history is which are the various products that the user has already visited, right? So user has already visited gel nail polish starter kit, and maybe one more product, which is and I think let's just change this because that is the key in our case. So, and the other is outdoor exploration kit. Now let's say if the user has just visited these two products, we'll use these two products, and now we'll say prepare product info text for user history. So it'll say it'll create a list basis the products it is seeing, right? And this is what we did for products as well. And once we have this, we are saying user history text, we'll create user history embeddings, and we'll do the same thing that we did earlier. So the only change, if you look at it in our approach now, is that instead of one product, we now have a list. So we are not looking at just one dimensional. This can be like, you know, a big list. For this experiment, we have just taken 2 items in the list, but you now created embeddings. And what we are going to do is we are going to say, hey, both of these, there's one change I want to bring in now, right? So these two products, if you look at them, a general user, what happens is you tend to visit different products, right? And you now want to do more of an exploration when you're recommending products. So one way, and there are various ways, but one easiest way is that, hey, we would have got 2 embeddings in this case, right? A list of 2 embeddings, right? We should ideally just do a mean of them. If you do a mean of them, you will be somewhere in the middle of one is toys and the other is beauty. So, and this is just one way. It's not the right way or the best way, right? My objective here is to just help you understand how some of these things work, right? So what we'll do is we'll import numpy as np. We'll take our user embeddings and we'll do a mean on them. So we'll say, hey, mean of history embeddings is equal to np.mean, and we'll pass in user embeddings and access is 0, right? So we are saying compute the mean, and this mean is what we'll use to then do a lookup against all the products, right? But to ensure that we are not checking against the products that the user has already visited or were part of history, we'll do some sort of a filtering of products. So filter products from products which are not part of user history, right? So products not in history, product for product in products, if product not in user history. Okay. Should work, yes. Right, so let's just see products, len of products not in history. Again, it's showing 19. Maybe these 2 are like made up products. Maybe they're not there in the catalog, which should be okay. Like, the catalog can change. An e-commerce company's catalog changes every time, right? Products go in stock, products go out stock, right? So len of products not in history. Now again, the same thing that we need to do is we need to create, we already have the products embedding available with us. We just did that. So I'm not going to compute the embeddings again. We call that product underscore embeddings. And what we'll do is we'll just closest products, we'll say closest products based on history is equal to find and closest mean of history products. So we are now, the method that we made, find and closest products, we are just going to take that method, pass the mean of the history embeddings and the product embeddings, and say, hey, give me the 3 products. And then for prod in closest products based on history, product is equal to products, and then we'll put in the title. Interestingly, I'm still getting, I think, the same results, other than the organic vegetable box, which is now replaced by stylish sunglasses. But what it has done is it has put me somewhere in the electronics and some sort of a fashion stylish sunglasses zone, right? So stylish sunglasses was somewhere here, and my electronics are somewhere here. So I looked at beauty. There was some product from beauty, and there was maybe that is not there in the catalog now, and the algo believes, and then based on the embeddings distances, that hey, these will be better matches. So your stylish sunglasses, your camera pro, and maybe my mean was somewhere closer here or something, right? So yeah. So this is it, guys. What we did is I helped you see how recommendations can be done using embedding. The concept is largely similar. You have a list of products, you build some sort of an info text from it. Don't just do your recommendations or searches based on titles. So you create that info text, then you create embeddings of that, you match those embeddings against catalogs. What I think you should do, if you can, otherwise I'll do one video for sure in some time in future, is how does performance degrade or stay when your catalog size increases? So how long does it take when you have 1,000 products? How, both for embeddings, how fast do the embeddings come back? And then how fast does the search work? And then we'll put in some sort of a vector database in one of the future videos and see how does the performance translate there, right? So from 1,000, 10,000, 100,000, 1 million products, how is actually the search and the embedding, how is it actually happening, right? So this was it. I hope you enjoyed the video. If you did, then definitely please press like and do subscribe. Thank you so much. Have a good time.